we've got another very interesting composite function revision question for you in this session. It's a typical level of exam standard, this question, so we really do need to come to grips with it. So part A, we've got f of g of x, alright? Now, here's my little picture, my assembly line picture. Now we know from f of g of x that the g function is first, okay, and then you do the f process on the output of the first stage, which is going to be g of x coming out of here, so then you do the f process on the g of x, and you get f of g of x coming out the right hand side, yes? Okay, let's flesh that out a bit more. Here's what we're looking for in what the processes do to the input variables x. So we have, this one is root x, so the input, the domain would normally be 0 to infinity, 0 included. The range would be 0 to infinity, 0 included, yes? And over here, this guy here is not a fussy function. He's prepared to take any old domain at all, that's R, and he outputs from 0 to infinity, including 0, as his y or his range values, yes? Okay, now, there's the situation for the first function. In, we get 0 to infinity, 0 included. Out, we get 0 to infinity, 0 included. And for the second stage, we have reals can go in, and 0 to infinity, 0 included, comes out. Yeah. Now you can see, guys, by looking at the compatibility area here, there's absolutely no problem at all, which we wouldn't expect because this guy's not a fuzzy function. He doesn't mind what he gets. Okay, so this certainly does fit, is wholly contained within this. That is, the range of the first function is wholly contained within the domain of the second function. So it's compatible, and we just write it like that. Therefore, f of g of x exists as expected. Yes? Good. Now, therefore, the domain of f of g of x is just going to be the domain of g of x. We don't need to restrict it at all. Everything's fine. And that is 0 to infinity, 0 included. Okay? The range of f of g of x is going to be the range of f of x based on whatever input it is getting. Okay, now it's getting an input of from 0 to infinity. Okay, and now have a look up here. That is the input values, or the domain values that go into it, are from on the right hand side of the y-axis in terms of x, that is from 0 to infinity, and therefore the output is going to be correspondingly 0 to infinity. Okay, do you get that? Great, alright. See how powerful a picture is and how useful it is in working out what's going on here. So therefore now let's hone in on what the rule is for our composite function. Is f of g of x is, rather than x squared, it is g of x squared, and that means it is root x, the positive square root of x, all squared, which just gets us x. But remember, guys, please remember that the domain is the domain of the left-hand side of this thing, which is from 0 to infinity, 0 included. Okay, that is the domain. So, would you be able to draw that and get it right in a sketch graph? Okay, there it is. Okay, it is basically y equals x, but it starts at the origin and moves this away. Okay, in terms of the x from 0 included up to infinity. That is your sketch graph of f of g of x. Okay? Did you get that? Well, jolly good show if you did. If you didn't, have another think about that and go back over it and make sure it is clear in your mind. Okay? Now this one's a little bit more interesting, which has a somewhat surprising result for many students. Okay, we're doing part B, so it's g of f of x now. Okay, the reverse situation to what we had in the first part. So let's just draw our little flow chart here and see what we've got. So we've got f of x is the first function inputting into our assembly line, and there's our graph of it, and there's our domain, which it normally would accept. There's the range. Now this guy here, you've got to be careful of him because he's a fussy function. He has a restricted diet. He can't take any negative values of x. But fortunately for us, the output of the first stage function f of x is exactly tailor-made to the input which this guy likes, so no problem in this instance. And of course the output for the square root function is from 0 to infinity and 0 included. Okay, so even though this guy's a fussy function, we've got a hand-in-glove situation over here where there's complete compatibility. This guy's range is completely and wholly contained within, or actually coincides with, in this case, the domain of this guy. Yeah? Okay, so we just put that in words. The range of f is wholly contained within the domain of g, and therefore g of f of x exists as expected. Yes? Okay, so the domain now of the composite function is the domain of f of x, which is R, isn't it? And the range of g of f of x is the range of g of x, which is generated by whatever input goes into it. The input is from 0 to infinity inclusive, so therefore the output is from 0 to infinity inclusive. Guys, you get that? So no problem. Now, let's go for what the rule is, and this is where you get a somewhat surprising result. Yeah, that's 0 to infinity. Now, g of f of x is, okay, it is the square root, or the positive square root of, not x, but f of x. Okay, so let's do that. Now, that is the positive square root of x squared. Now, where many students fall into the algebra ditch here is they think that's x. It ain't x, guys. It is modulus of x, modulus of x. Yes, I know. Please put your jaw back up to where its normal position is, and I'll explain. X, of course, is any real number, okay? Because the input into this thing is any real number. Remember that? Now, why did I do this? Why did I do that? Well, I'll show you why. Have a look, and please absorb what I'm saying. Let's do a table of values. I can have any old value of x, remember, because x can be any real number, can't it? Yes, it certainly can. Now, I'm going to square it. There it goes, right? Now, what I'm going to do now, guys, is I'm going to do the positive square root of x squared. I'm going to do this, the positive square root of x squared. Here it is, here it comes. Can you fill in the line? Well, here it comes. Yes, now, I want you to look very closely. See these values of x here? Some are negative, this one's 0, and these are positive. But once you get the square root, the positive square root, in fact, of x squared, they all come out positive. They all come out positive, with the exception of this one, of course, but the negative ones all come out positive. Do you see? Do you see why now that the positive square root of x squared is not x, it is modulus of x, yes? It is modulus of x. So please sock that away in your memory banks and bring it out when necessary. That is a really good little tool in your mathematical arsenal to not fall into the algebra ditch when they pull that stunt on you, okay? Now, here's the graph. So you've got x is any old real number, and g of f of x is the positive square root of x squared, which happens to be mod x. Mod x, yeah.